I'm going to turn it over to John.
Thank you, and thanks for the opportunity. Bear with me here as we sort of switch the presentation. That's me and my daughter and son. I'm smiling. I'm in New Jersey. Just so, here it is. So my son's face. My slides aren't quite as colorful, but I was introduced. I'm an oil and gas operator in New York State. I'm a board member of the Independent Oil and Gas Association. Been operating and drilling wells in New York State for 30 plus years. And as background, I started my career as a graduate of Penn State and worked in the service business, and then became an engineer at Lenape. You'll see here, I put this down the bottom. I worked on the 92 GEIS as well as casing and cementing guidelines when we created aquifer conditions so we could literally drill oil and gas wells, hundreds of them, through the Jamestown aquifer. We've done it. There's no pollution. We've been doing it for a long time. So I can say, as a matter of fact, that New York has a pretty stringent regulatory program. I'd like to start, I'll take a little change from what Tim has done. Some of the things in here you'll see are duplicates, but what I'd like to start out with, I noticed on the internet there's a study by the Energy Information Administration. It's basically a beta site where they're evaluating, the states, the different states in the United States, and how much gas we consume or how much energy we consume and where we get it. And I found this interesting because you'll notice, I'll borrow Tim's pointer here, you notice this one way over here happens to be natural gas. And this is New York's energy consumption in 2010. Now, I'll refer to this a long time into this presentation because when you look at the other side of our electrical generation, the other thing's interesting is this long amount happens to be natural gas. Natural gas seems to be pretty important to this state. Now, I've been drilling oil and gas wells in New York for a long time, and I realized that my business is basically selling this commodity. But the interesting part is there's no better place to sell it than New York. I mean, this is a state that relies on natural gas. There is no doubt about it. Some historical background. Tim mentioned this. The birth of natural gas, Fredonia, New York. Watched his neighbor drill a water well, wasn't any good, it had gas in it, so he drilled a gas well. Hey, we're not geniuses, but we understand where value comes from. What's created the issue where we are today, I think, is a misperception. And Tim gave you a lot of background on how old this is, what we've done. This happens to be from a lawsuit. And it's a recent judge's ruling, a lawsuit, I think in the town of Dryden. And essentially he said, this provision, and he's referring to the oil and gas law in New York State, the revisions in 1980, he says, was last amended more than 30 years ago, long before the potential use of hydrofracking to recover natural gas from the Marcellus Shale in New York could have been anticipated. Man, was this guy wrong. I mean, I'm not going to, you can't blame an attorney in Dryden because he wasn't in the oil and gas business, but believe it or not, during the 1970s, those of us who were around then realized there was an energy crisis. We're running short of natural gas. Every state in the United States, my company, Lenape Resources, was created when the utilities in New Jersey decided that they were going to find natural gas to supply the utilities in New Jersey. So the Department of Energy, the utility commissions, and in New York State, NYSERDA, decided that they're going to find more natural gas. This is a map, this is date down here, 1980. This happens to be the same time that New York starts to create its regulatory structure. New York's regulations, New York's guidelines, New York's laws were developed because of shale gas, because of the idea we have to find more gas. So when you say that we never thought about it, the funny thing is, it's the whole reasoning for it. So when we talk in New York State about You know, all this is new, all this is happening now. We got, you know, we're gonna have to take our time. We've been doing it since 1980, folks. I mean, we created this whole scenario to get to this point. The Department of Energy, NYSERDA, I mean, we've spent huge amounts of money to get from where we were in the 70s to today. We finally accomplished what the Department of Energy and NYSERDA and every oil and gas business in this country has been trying to do. We're getting to that point, and now somebody wants to say, nah, it's the wrong way to go. So that map I showed you previously, if you look at it, it's a little bit crude because we didn't have quite the technology with computers that we have today. But if you look at some of where these things are, you'll notice this happens to be a map of the plays today. A lot of them end up being the same thing. This is where we've come from. This is where we got to from coming back in the 70s. We've made it to the point we want to be. We've gone from just drilling these basically what we call conventional reservoirs into the unconventional. We've been able to tap the resources that are down there to really make a difference. And this is what we're looking at. This is just a small piece of Marcellus Shale. New York State's full of a bunch of zones and areas that have gas and oil. Has been for years. These are things we've been developing. What you hear a lot of talk about, essentially, is this Marcellus Shale. You notice this is a stratigraphic column. And actually, this is deeper basement, shallower surface. So you have the Marcellus at the top, you have the Utica here, but there are a lot of other zones. And the technology we use today, the horizontal drilling, the hydraulic fracturing, I mean, essentially, this is where New York's development has been. I have wells from here to here to here, and I've drilled wells over here. So, I mean, pretty much this, actually, the only work I've done down here, this little spot right here, did a water well at Lido Point when I was with my previous company. We actually, as Tim said, it's very important in the water well business. When you drill on the island, you actually drill through salt water to get fresh water. So they cement and case like we do in the oil and gas business to get good water wells. This is out of the SGEIS. It's a presentation of the Marcellus Fairway. This is the area that's perceived that the Marcellus would play. The hatch mark here is essentially what people are terming the sweet spot. This is the Utica. And when you overlay the two sweet spots, you basically get this as the initial focus area. So you see, it's not the entire state. I'm over here. I've drilled up here, and I think there's potential everywhere. But for this discussion, we'll focus on where everybody else thinks the initial focus will be, and that's pretty much down in this area. How are we going to do this? Tim said, it's the combination of horizontal drilling and hydraulic fracturing. It can't just be done with horizontal wells. It can't just be done with hydraulic fracturing. Really, the industry has progressed to the combination of these two, and that is the state-of-the-art methodology that's working. And truthfully, it will not only work for the shales, it will start to work for the other reservoirs. I'll give you a little bit of an explanation of why the shallower rocks in Pennsylvania, like the National Forest, don't work as we get along here. But you see, Tim did a good job. Here you got a vertical well in the same formation, okay? And this is all you get to recover from. This is all the resources you get to recover. Where you do it horizontally, you get to recover all of this. It's a matter of this, okay? When you start to look at contact area, you come down the whole way down here. It's 957 times the vertical. When you drill a vertical well, you can do that same well horizontally, but then when you hydraulic fracture, you end up contacting more reservoir. The more you contact, the more you produce, the more the economics work. Guys, this isn't an option. This makes the resource recovery we have work. Tim mentioned this, first horizontal well in New York was 89, which is interesting. About 2/3 of the U.S. rig count's non-vertical, and close to 50% of rig count drilling horizontal wells. Hydraulic fracturing started out, fracturing granite mines. I worked on a project in Vermont and that's a state that actually has a moratorium on hydraulic fracturing. I guess they probably don't realize that a lot of the water wells in Vermont are hydraulically fractured to get the amount of water they need for the municipalities and the commercial operations, but that's a secondary point. The issue is hydraulic fracturing and the busting up of rock is used in a bunch of different applications. Typical Marcellus well, Pennsylvania, slick water, 400 to 500,000 gallons per stage. That's where, where people get confused. They say, well, why so much water? Because it's the area we contact. What happens is we go from a single stage treatment before that was covering 100 foot to 20 stages that are covering 5,000 feet. So what you end up doing is now you have 20 of those 300,000 gallon stages. Now you have 6 million gallons of fluid. So that's how you get the rationale for the total volume of fluid. You have to contact that area or you can't get the reservoir. This will give you a little reason why those shallow formations are harder to drill horizontally and hydraulically frac. When we drill a horizontal well down here deep, okay, below 2,500 feet, because in physics and in stress, fractures are created perpendicular to the least principal stress, okay? So down here, they're created vertically. As you come shallower, they sort of angle themselves, but in a shallow well, it's a horizontal fracture. So when you do the hydraulic fracturing, it's actually growing like a pancake. So if I drill a horizontal well shallow and I tried to hydraulically fracture it, I'm not adding to what I did. I'm literally creating a fracture around the wellbore. But when I do it vertically and when I do it deep, I'm drilling this way, I'm fracking this way. What we're able to do, the technology today that the industry has is phenomenal. And you basically, the reason we know this is we do seismic analysis that tells us how things grow. This is a lateral presentation of the fracture growth. So you can see from this wellbore drilled, you can actually see how the fracture is growing away from it. Then we also have that same technology that allows us to analyze how high the fracture grows from the wellbore itself. So we not only know how the fracture grows this way, we know how the fracture grows this way. And why do we know that? Tim said it. What we want to do as an industry is maximize the recovery from the rock. So if we can basically bust up the rock to a certain area, then we know we're draining that area. So when somebody says, well, what about, they're going to fracture into my water well, they're going to fracture into this or that. We don't want to do that. All we want to bust up is that rock that has the gas in it or has the oil in it. So we're able to do that. Now I'm going to talk a little bit, get a little bit into detail in New York. What's happening in New York? New York, you're still allowed to drill and hydraulically fracture vertical wells. You're still allowed to drill horizontal wells. What you can't do is you can't do high volume hydraulic fracture. And the dilemma that creates is that, as I've shown you, is pretty much the only method to develop the resources that we have. So if you're not allowed to do that, you're basically dead in the water. I can tell you, I've drilled a lot of vertical Medina wells, and I've drilled some shallow oil wells in the southern tier. And right now, vertical Medina wells just economically don't make sense because we're competing with the resource being recovered in other states, Pennsylvania, Ohio, West Virginia, the Southwest, the Bakken, wherever it is. I mean, this is a global marketplace for the resource. What New York did, the old GEIS we worked on and finished in 1992, covered pretty much the industry and the development. What the DEC decided to do when we went in and started to permit horizontal wells with high volume hydraulic fracturing, the DEC realized that this was the wave of the future. And in doing that, what they wanted to do is supplement that GEIS to basically take care of those common practices that we would be using for high volume hydraulic fracturing and horizontal drilling. You know, multiple wells from a single pad, drilling in as you know, we wrote spacing laws in 2005, 2007. The state, in doing that, under seeker, goes out to public, and we're where we are today. We haven't been, we sort of died in the water evaluating, and now we've got a document that I'm sure if anybody's read it, it just keeps getting bigger and bigger and bigger, and I'm getting to the point where my desk isn't large enough to basically handle all the paper. New York has done a tremendous job in their development of the SGEIS, reviewing everything involved. I mean, it covers those things that we're changing to apply the technologies of horizontal drilling and high volume hydraulic fracturing and recover the resource that's under New York State and make a difference. We've got road use and planning. This is all, I mean, these are requirements in the SGIs. Pad locations, pad construction, water plans for access to disposal, waste plans for accumulation, from accumulation to disposal, well construction and development standards, production facility development and monitoring. New York has gone a little bit overboard. In New York's, you hear some discussions about, well, we don't have to have regulations. The regulations don't have to change for us to be able to drill. I can tell from a practical application what's done. Every permit that an operator applies for in New York State is site specific, okay? The GEIS and the SGEIS contains guidelines on the practices that are common across the industry. When we apply for a permit, what we have to do is take those generic guidelines, okay? We advance them to be specific to where that well pad and well bore are. So if you're near water, if you're in a grassland versus a forest land, if you're on a hill versus in a valley, if you're on top of the hill versus on the side of the hill, all those things are applied site-specifically based on the generic guidelines to help do the right thing. And New York's regulatory structure is developed. It's supposed to be developed, not to prevent development, but to assist development and mitigate problems. That's the whole design of our regulatory structure. That's secret. That's what New York's supposed to do. What's happened today in this whole, stalling and the high volume is to me, it's an embarrassment to this state, because we really did have a very good regulatory program and structure development under seeker, and somebody basically took that and threw it in the toilet. And now they've stopped it. I mean, I traveled in 1992 when we went to the public hearings on the first GEIS. I can tell you, I was at numerous hearings. I was at a hearing in the city of Ithaca that there were only 4 people at. Could you imagine a hydraulic fracturing meeting in the city of Ithaca today? I mean, we'd have to figure out where to park the buses. So, I mean, that's how far we've come. We've come from, where before we were seriously looking at science and developing something to move forward, to right now it looks as though the whole thing, what's happening is they're looking at things to stop it. You see, I mean, what you're seeing in these 2 slides is essentially all the requirements that have basically discussed and analyzed to prevent any problems in this new process. It's a huge document. If you have the opportunity and you haven't read the whole thing and you say, okay, well, somebody tell me what I should look at. From an operator's perspective, okay, there's a whole bunch of stuff in there about geology radioactivity and science, and I'll show you there's 39 pages talking just about the chemicals we use. What I would tell you to focus on is look at Chapter 7, Appendix 6, and Appendix 10. Those are really the areas that will tell me what I have to do to operate in New York. And what it will do for you is it'll give you an idea of those things I have to do and fill out and watch. And I, this slide's it's a little older, so there's no, you notice there's no page numbers or anything because everything seems to be in flux. But it doesn't seem like they changed the original document. They just keep adding to it. So it should be fairly good. Take a look at what's covered in this document. We cover land use. As Tim mentioned, horizontal drilling is just, it's phenomenal. I mean, now we're able to basically, now we can locate a well where we want to instead of directly over where we want to be. I mean, when we deal with landowners and farmers, we'll have some guys, they know we're going to build an access road. So in talking to a landowner, what we'll do is, where do you want the access road? Where do you want us to be? So we can start out. We've done things, we've built pads, not in this case of big horizontal pads, but we've done this now in vertical drilling, where we come in and we'll build the access road so that it provides access for the farmer in the long run. We've taken down hedgerows that the farmers had there for 20 years, and he'll say, God, I would just love that taken out of there. We'll clean up entire hedgerows. He'll open up farm fields that he didn't have before. So the cooperation between the oil and gas industry and the local landowners, it's always been fairly good. What you see now in the development of larger scale multi-well pad sites is because, instead of the drilling and the drilling and operation taking a couple of days, like a small vertical well, now you're there a couple of months, maybe at most a year. So what you're doing is you're able to basically take this area you're going to operate from, and from here, they're basically recovering the resource from a square mile around that. So they're able to use things now. There's pad liners and all kinds of things that basically make the pad we're working on impermeable. I mean, we have some locations in Pennsylvania that they come on site after it rains. They come on site with a vac truck and suck the rainwater up because it doesn't drain into the soil. I mean, so if people say, well, what about the spills? What about that? I mean, a lot of those things are handled now because we'll build the site, and then when we come back and reclaim it, all that stuff can be removed. It's a temporary disturbance. You remove it, reclaim it, and it looks, except for the well and some of the tanking. But here's what you see. You see these, the smaller pads, but the recovery is much larger. Why? This is a presentation that Range Resource did. And you can see as they start to get longer lateral wells that they were doing in 2009, 2010, these 7,000 foot laterals where they're contacting that much more rock, their production, is staying that much better. I mean, and I was reading one of the reports that Cabot presented, and some of their results in Susquehanna County are just absolutely phenomenal from an operator's perspective. Tim talked a lot about groundwater. I'll spend just a little bit of time. He's absolutely right. In New York's requirements, the closed loop system is mandatory. There's mandatory background water testing, ongoing testing during the drilling, after the drilling. All those are required. It's not an operator option in New York State. Extra casing and cementing. We literally have to do pressure testing of the casing and the cement before we can do any completion or hydraulic fracturing. So New York, in this document, they've done just about every possible thing you could do, and they've actually went overboard to prevent anything from happening. One of the things in the SGIS that I have a personal problem with is the setbacks and prohibitions. They've included setbacks and prohibitions that, in my in my opinion, as somebody who drilled a lot of wells, I mean, when we've drilled wells directly through the Jamestown aquifer with no problems, what this actually accomplishes is inefficiency. You're going to end up having to drill more wells. You're going to have to drill wells in places you don't want to, all because they created just a geographic setback from a spot, whether it's an outline of a primary or principal aquifer, or a house or anything else. When you start to limit the flexibility that the landowner and the operator and the technical people have of doing things the right way, because you create a paper law or setback, you start to create problems. What we were hoping for as an industry, we're hoping that these don't become fixed. They become a guideline that can be adjusted if you can justify it. So it allows us to say, look guys, we know if we drill this well here, okay, even though it's setting on top of a principal aquifer, these other conditions will be that much better. That's what we're hoping for. And whether or not it happens, this happens to be a map of just in this Marcellus region. These are the areas with the setback requirements. And this doesn't even include some of the grassland and woodlot requirements. New York's water testing program, baseline sampling prior to drilling wells, if you have a multi-well pad, sampling and analysis for 3 months, 6 months, and 1 year after the hydraulic fracturing operations are done. We're done until the last well on the pad is hydraulically fractured. So you hear a lot of discussions of, well, they're going to be coming back and they're going to be fracking all the time. A lot of the pad development now is being done, sort of in a time, let's call it a timely fashion. They're developing the pad because it's economically feasible. What is coming to light, though, is, as you noticed in that stratigraphic section of New York State, there's multiple layers of shales. What we're realizing is we may be able to use that same pad in the future. If it was used to develop the Utica, you may be able to use it to develop the Marcellus. Or if it's used to develop the Marcellus, you may be able to come back and develop the Utica. And what that does is just allows that much better an opportunity, minimizes the impact. You're using what you have as best you can. This is another Range Resources presentation. You have a depiction of it here, but New York, we're required to have at least 3 strings of casing and with cement outside to protect the interior where the gas and hydraulic fracturing is from the outside, whether it's the groundwater or just the rock or whatever. So New York, our program is very regulated, very strict. You hear some discussions in various means. Some people, I saw a presentation, Sky is Pink or something. I saw this thing, and a professor mentioned that 1 inch is not enough cement to protect the outside, the groundwater, from the inside. 1 inch of space and cement. And I looked at the New York regulations. I haven't found anywhere where we're allowed 1 inch. So I don't know if it was done intentionally to try to deceive people, but New York State is, back when we were doing the casing and cementing guidelines, there was a lot of work done with the service companies, whether it was Halliburton at the time or Dowell or Schlumberger, on developing the amount of contact and the surface area of the cement to basically withstand any of the pressure and any of the operations inside. And now remember, as you see here, you not only have the one, but you have multiple. So if this is the production casing here with the tubing inside, you have this casing with cement outside, this casing with cement outside, then this casing. And in a lot of cases, and there'll be a conductor casing down into the water zone with another string of cement outside. So all the work here, and as everybody knows, it's sort of like driving, it's like driving a bulldozer on soft soil. If you have a bulldozer with small tracks, it sinks. If you have a car with skinny tires, it sinks. If you have a bulldozer with wide tracks, okay, it won't sink. And that's essentially what happens is you apply the force over a larger area. You disperse it. So the penetrating force to bust something up is diminished. That's the way all this works. Here, you see the aquifer up here with the strings of pipe and cement protecting it. In New York State, a lot you'll have a saltwater zone. You'll have the Salina. Then actually, the Marcellus is right here in this zone in most cases. And then if you were doing a Utica well, and this would be missing on the Marcellus, your production zone is down here. This whole section, okay, we've got, all that has really not changed in New York. The vertical section of the well in our business is the same. What really has changed is from this point down. That's the changing of the guard. In New York State, we've had our casing and cementing guidelines since the 80s. 10,000 wells drilled in New York State, no water damage. So when somebody says, well, we have to do a health study, we have to figure out what's going on, I mean, what better study than history? I mean, if we want to wait for the 50 years until Pennsylvania has developed the Marcellus, completely developed it, and we've got 50 years of background, and then we'll start in New York, that's fine. But you guys remember those charts in the beginning? We're going to have to get that gas someplace. I'd prefer it comes in our backyard. Tim talked a little bit about water. Well, actually, a lot about water. I'd like to talk a little bit about the water consumption. There's, running out of water. One thing we have in New York, and everybody talks about, it's a precious resource. Water. I mean, we have the Finger Lakes. We have, builds community character. People come here to vacation. When you look at the consumption of water in New York State, 15 billion gallons of water a day. Hydraulic fracturing estimate based on what's happening in Pennsylvania, and I think this is a high estimate, okay? Because Pennsylvania's got a lot more areas that developed than New York does. If you look at this number, the industry wants to use a little over 0.1%. These are an analysis of the water used per energy created. You'll see up here where shale gas development is, okay? And you go down here, and it's interesting because when you start talking about the biofuels, the amount of water needed to develop that energy resource, and we can't live without energy, ends up being a lot larger. What's in the water? Chapter 5.4. 39 pages information on chemicals and what's in it. A lot of that information, I will tell you, is old. A lot of stuff we don't even use anymore. Haven't used it in probably 40 years. But, as Tim said, what we basically do is these, like every other industry, and this is sort of an indication of the chemical. Like every other industry, the oil and gas industry needs chemicals to perform a function. Okay? Whatever it is, whether it's scale inhibitor, whether it's a friction reducer, whether it's to stop microbes from growing, we need it for a reason. These industries need it for a reason. Everybody uses chemicals. Tim mentioned Frac Focus. This is the front page of the website. You can click on the map, zoom in, look at any well you want. I imagine New York State will end up being a part of that. But this is a point I want to make. When we use everybody uses chemicals. I mean, this is chlorine. When it's handled and used properly, it works. We drink chlorine every day. What happens when the water comes back? There's been a lot of concern about, where the water's going to go. It's going to be dumped into rivers and streams. Well, as you noticed in the previous slides, all the flow back is handled in tanks, within steel, all encased, It's gonna be controlled. So now that we have it, we gotta deal with it. These are sort of the opportunities of handling. You have inject underground through disposal wells. That one I like. I actually, a partner and I have the first 2 commercially permitted disposal wells in Pennsylvania that's been in a long time. It took us 3 years to get them, but we actually have the 2 newest commercial disposal wells in Pennsylvania. And we're, believe it or not, what we're doing is we're putting it back into a depleted natural gas reservoir. So what better place to put it than back where it came from? So that's an option. This hauling to municipal wastewater, I'm not going to talk a lot about that because what's happening, if I use Pennsylvania as the example, the Marcellus fluids produced in Pennsylvania, none of them are really going into rivers anymore. The only thing that's being handled is the produced fluids that were handled previously by these treatment plants. And in New York State, whether it's the federal program on it, the water program handled by the feds, or New York's Speedy's program for operating sewage treatment plants, they're not going to let a sewage treatment plant handle anything until they're done with the head test where they analyze what's coming in, they analyze what can go out under their permit. They're not going to let anything bad go into the surface waters in New York. The commercial or industrial wastewater sites, that you may see. There are facilities like in Niagara Falls, New York, that have been handling ugly, bad stuff for years. Years and years and years and years. They understand chemical treatment. They understand material handling. And the industry in general is looking at the practice of possibly taking some of the materials like the barium and the strontium and the heavy metals that can cause issues and turning them into, secondary sales products, something of value. Those materials are used in the electronics industry. They're obtained around the world today by solution mining. We just happen to be in the natural gas business, basically recovering natural gas, and as a secondary product, we're solution mining those things during the drilling and completion operation. So why don't we combine the two? Save us from running to China and other places and drilling solution salt mines and solution metal mines and get it from something we already have. So there are companies coming into the business looking at that. But right now, the truth is, there's just not enough of those materials to really make it worthwhile. So they're being treated and handled. Recycling, the reuse of flowback fluid is really common. I can tell you as the operator of the 2 commercial disposal wells, and everybody talks about all this fluid that going to Ohio, and talking about where our business model is going in Pennsylvania, our biggest concern is there's not going to be enough fluid to dispose of because most of it's being recycled. And now the operators have gotten smart enough that instead of a Lenape basically having to handle all its fluid by itself, they're using centralized treating facilities, and the resultant cleaned up fluid that can be used, even if I'm not doing a hydraulic fracturing treatment, and Tim's company is, Tim can come to that facility and get my retreated fluid. So now we're operating as a cooperative, saying, okay, historically, if I'm not using it, if I'm retreating my flowback fluid and I stop hydraulic fracturing, my need for fluid goes down. So I got to take that to disposal. But his need for fluid is going up. So he comes in and he basically, instead of having to go to the river or the stream or the municipal water supply system, he gets to use my recycled fluid. This happens to be an example of, what in, out. Recycling it's growing into its own business in Pennsylvania. There are numerous plants in Williamsport in the northern tier, now in western Pennsylvania and southwest Pennsylvania that are going in specifically by separate entities to handle fluid recycling. What happens, when we do all this? This is sort of my pet project. As you saw in the beginning, I was involved in revamping some of the Title V, Article 5 real property tax law on oil and gas, trying to sort of get it so it works throughout the state. This was I have a little issue with the town of Avon, and I did a talk over there, and they have a small parcel of land, about 9 acres, that they have a town barn on. I actually supply them with gas from my gathering line. But what I did was I took the wells from Pennsylvania across the border, and I brought 4 of those wells into Avon and put them on a 2-acre pad on the back corner of their property. And I said this is what would happen. But essentially, this is the annual property tax created from those wells, producing about, probably 1,000 feet from Interstate 390 and about 500 feet from a major Tennessee gas transmission line. And the impact on the community and truck traffic and anything else, they wouldn't see it, because literally their property is right beside an interstate highway, 390. But needless to say, that didn't change anybody's thoughts. The other thing the industry brings is jobs. I mean, all kinds of jobs. You'll hear people talk about, well, they're going to come, they're going to go, they're going to leave. I came to New York in 1984. I haven't left yet. I'm a petroleum engineer. I have no idea why somebody would say, well, they just come and go. People literally move to where the jobs are. People also decide where to live based on taxes and homes and community and other things. And if you can combine that for anyone, the jobs, the people, the opportunities stay here. Economic impact. This was a study done by the Manhattan Institute. And you see, this is a projection for New York with $11.4 billion economic output. I had the opportunity at the beginning of the week to be in Albany at the Oil and Gas Association's lobbying session. And it's interesting because we're down there and we're walking around Albany with, since it's lobby day, there's a whole lot of people there. I mean, and everybody, it happens to be, since we're before the budget, everybody, it's a legislative and a budget lobbying day. So the majority of the people are there with their hands out looking for something out of the budget. They want something, they need something, they want something changed. This industry is there looking to add this to the state, and we basically get shunned. That, ladies and gentlemen, that is the biggest embarrassment that this state has. This is an industry that wants to come here. We've never been shy of regulations. We've never asked anybody to cut any corners. All we've ever asked for is the opportunity. That's it. Just the opportunity to come here, spend money. You don't have to give us a dime. I'm a small company in Alexander, New York. I've spent over $100 million in this state drilling oil and gas wells. Well over $100 million. I brought a company out of Denver, Colorado, spent $10 million doing a seismic program in Wayne County, New York. Middle of nowhere, Wayne County, New York. How many people know where Sodas Bay is? There's a little store on 104 that sells Carhartt clothing. When the crew came in to do the seismic work, most of the guys were from New Mexico. Some of them were Mexican. Okay? It's hard work. They bought that store out of every boot, every coat, every glove, everything the guy had. The guy, he had no clue what hit him. He did more business in 2 weeks than he did in his lifetime. Granted, they left. They're gone. We have a horizontal well that has a 2,500-foot horizontal. It's been sitting there for 4 years. I can't fracture, can't do anything with it. And probably the state's looking at me to plug it. It's an embarrassment. Yeah, those guys came. They spent money at the restaurants. They spent money at the bars. They spent money at the hotels. They probably spent more money, that seismic crew, than the entire community did. In those 2 weeks, they probably spent more money than the community did in a year. They're going, I didn't think it was bad. I've been at presentations where people say that's a bad thing. And maybe I've been tainted by being in the industry, but if somebody comes to my community, as long as they're not damaging anything, I'm looking at anything as value, especially New York. Ultimately, what do we get in this state? This is what we get. We get clean energy. I did a presentation at Columbia University focused on the impact that natural gas has as it's used more heavily in New York City than oil or coal or anything else. And we have an incidence of lowering of asthma. It's linked directly to increased graduation rates in schools because the kids are healthier. This isn't, all we're trying to do is we're trying to help. But this is the thing that sinks home to me. It's the opportunity of one of the lowest cost energy sources that's out there. New York State's natural gas costs, consumer natural gas costs, are like the 4th lowest in this country. We have some of the lowest natural gas costs in this nation. And this state won't let us produce it here. We're reaping the benefits of the extra gas produced in Pennsylvania, West Virginia, every place else. And you want to talk about NIMBYism? That to me is NIMBYism. It's not my backyard. You can do it someplace else. I'll reap all the benefits. I'll pass all those cost savings on to all my consumers in New York. Everybody's got a lower energy bill at their house. Why? Because those guys in Pennsylvania are working their ass off. That's why. So the next time you're sitting around, the best thing you could do is send a thank you note to the Pennsylvania DEP and say, we thank you for getting this right, because New York can't. They've evolved to a set of regulations that we've had since the 80s. We've had it right. We just don't have the opportunity to try it. Pennsylvania realized it was an opportunity they couldn't pass up. Gentleman Anthony Meggs at MIT basically sums it up for me. The shale gas is transformative for the economy of the United States and potentially on a global scale. Guys, that's it. This has changed the world. I've been in the hydrocarbon energy development since I got out of college in 1980. And I can tell you, I've never, ever seen the opportunity we see today. This is absolutely phenomenal. The biggest change we have and what's causing the biggest problem, and we all have to live with this, is that concept of NIMBY. Before, we were allowed to burn oil, and we could burn gas, and they were drilling wells down in the Gulf of Mexico, they were drilling wells in Southwest Texas, they were drilling oil wells in Saudi Arabia, and we didn't see any of that. We used the gas, we used the oil, we used it, and it was great. Now all of a sudden, you got to see a drilling rig for 6 months because you're going to get the gas from it. It's, can't have that. It's like telling somebody you can't build a Walmart because I don't like bulldozers. But when the bulldozers are done and the facade of the Walmart's there and everybody's shopping and everybody gets their cheap food, they're happy. It's the same thing. There's always going to be some disturbance and some problems to get what we need. Thank you.